Hello and good day once again. In the last two videos, I've shown you how binary addition is done using half addition and full addition, with a half adder using which adds 2 bits and a full adder which adds 3 bits, both of which will output the sum and the carry uh, using Circuitverse. Now in this video, I'm going to show you how to create an arithmetic logic unit that does addition of 4 bits using full adders. But this time, we are not going to use the full adder that we have created because the full adder is already supported in Circuitverse in the miscellaneous elements panel, particularly in the group 4. That's why in the miscellaneous group. Let's now create that sheet and name it ALU with adder. Now in this case, we are going to have two sets of inputs. We have A and B. So the first set we'll call A, designate them as A0, A1, A2, and put them downwards. No? Uh, Point them downwards. This is our input A. And we'll copy them. Control C, Control V, and we'll put them in between. I'm sorry, I between A, in between A, just like that. Okay. So this will be our A0. This will be our B0, or rather uh, A1. This will be our A2. And this will be our A3. This will be our B0. Our two inputs will be A and B. This will be our B1. This will be B2, and this will be B3. Likewise, we'll also have four outputs. Okay, so our outputs will be, let's put it up, B, S. We'll call this S a sum. S0, paste. So anyway, we'll just put them down. It happens. This is for our 1. Let's put this downwards. Call this S1. This will be for our S2, and we'll put this downwards. Now let's put this upwards. This will also be upwards, and this will be our S4. What we are doing here is we're going to add all bits one by one. We are going to add A0 and B0, A1 and B1, A2 and B2, and A3 and B3. So instead of using our own full adder, in the miscellaneous tab, we have a full adder already. Okay, we can put the direction to left. Okay, so this is our input for our A, this is our input for our B, and our input for our C. In which case, we'll provide a constant input of 0. This is our constant input of 0, and this is our constant input of 1 for the first carry. We could have used a half adder, but there's no half adder provided by Circuitverse. However, we can easily convert a half adder into a full adder by switching the last input to 0. This is constant 0. So the third will be always 0. Okay, and then we are going to add. Okay, this is B, A0 and B0, and this is added to. Let's enlarge this so it'll be easier. Now we will have a carry out and we'll have a sum. The sum we will connect to our S0. Okay, and then we are going to add A1 with B1. So we are now going to have another adder, another full adder, and this time, okay, we are going to also point it to the left. Okay, so the last carry of the first adder, we'll name this FA1, FA0. So, okay, and direction is up. It's the label direction that's up. Okay, you have to reconnect because no, it's wrong. The direction should be left. Okay, so this is connected to 0. I'm sorry I have to do this now. I've made a mistake. This will be it. And we'll call this the second adder as FA1, during which we are going to add the last carry of the first FA0. So let's change the label direction to up, to our next to C, which adds the last carry to the next half adder. It makes sense. And then our B, we're also going to add our B. And then our A, we're going to add. Okay, so we are now adding A0 with B0 and A1 with B1. Now our sum for A1 and B1 will be displayed to S1. Now we'll do the same. Can we just copy this? I hope we can. It does not, so therefore we'll have to add this. Okay, and the direction to right, rather left, and then the label direction to up, because we will relabel this as F2, FA2, the second, the third full adder. So the first input is the output, is the carry, the last carry, and A and B is added. And we'll add A, and then the sum we will set to S. And then for the last time, we are going to repeat the process. We're going to have a left direction and a label direction up, and we'll label this as FA3. This is our third adder, fourth adder rather. First input of which goes from the last carry, second input from B3, and the last input is from A. And then the last carry we are going to just use an output. This is C4. Okay, and the orientation is right. This is our last carry. And then we'll have what we are having here is an ALU which does addition. Okay, let's try this. Okay, first 0 plus 0 plus 0 is a 0. Okay, we'll try 1 plus 1. 1 plus 1 is 2 because 0, 0, 1, 0 is 2. Okay, we'll try 1 plus 2. If you set b1 as 1, that is 2. Okay, so 1 plus 2 is 3. Okay, 3 plus 1 is 4. Okay, and shall we try 6? This is a 6. 6 plus 3 is 1001, which is 9. 6 plus 5, 5 is 101, is 11. That is 8 plus 2 plus 1, that's 11. So this is an ALU which does addition. In the next video, I'm going to create another ALU which does both addition and subtraction. Bye for now and see you then.